All right. So he hasn't merged this yet, but I don't even think he's probably seen it. Most likely. And given that the last activity was mm, let's see. Right. Looks like no, April, May. Lots of stuff in May actually. Very cool. So he may be around. He just may not be he just may not be checking it today. Let's do a few things. Let's see. So let's go ahead and get like day 6 stuff in. And then let's try to clean some stuff up today. I think we can clean some stuff up and then we can. What the heck? Docker support. Oh, that's pretty awesome. Anyway, so let's go back here. Folder view. So we need to be in team. No, whoa, look at all those configs it dumped in here. I don't want that. Team Explorer. Let's go to changes. Okay, let's do. We'll do day 6 updates. Render. And input. Okay, so we should have day 6 changes Let's see. Let's look at commits maybe. Let's just see. Make sure I have day 1, day 2, day 3, day 4. Let's edit this commit message to actually, if we can. I don't think we can. It's okay though. Neat. GitHub pages. Look at this. Cool. Wow. I love this. Midnight. That's neat. I'm gonna try not to get distracted, but I'm just gonna put to do. Actually, you know what? I'm not gonna worry about it right now. Oh man, it. It automatically. I wonder if I can roll it back. Yeah, let's roll this back. I wonder how I can do that. In the old house, long to be. Yeah, let's see if I can roll this back. Actually, let's get this. Let's. I wonder if I can fetch. I'll go ahead and fetch, and then I'll see if I can. Wow. No, this is the commit. I want to revert this one. Okay. And I think hopefully that reverted this. Oh, what's up? Cheeky Trooper, don't worry about it, man. We didn't get a lot done yesterday. Well, we kind of did, but I was very distracted. It was a very, very long stream, and we just it just seemed a little bit monotonous yesterday. We just didn't get a lot done. Okay. So I will stop fooling around with all this stuff because I'm going to. So I don't know. I need to. I wish that there was a way that I could. Basically, so this project has. I wonder, you know what? I could probably get Boltorius to actually stream the info. No, yeah, Bo, I had it a long time ago. I've just been wearing a hat. I don't know why. I just started wearing a hat, so but anyway, so this all of our work up to this point is on GitHub. We're using a let's see, pull request. We're using OpenGL 4-sharp library that I've issued a pull request to support structs in GLSL. Hopefully, this guy, the last time this repo was active or had active commits was in April or May, so not too long ago. So I'm hopeful that that he'll see this soon and he'll merge it so we don't have to continue using a forked library. I would rather use his and not my rendition of it. So quickly, just to recap the other day. So we went through. We wanted to create a generic sort of renderer. And we were unable to really do it in a generic way because of this VAO and how it works. The VAO basically is going to contain all our vertex indices, normals, tangents, UVs, that sort of stuff. And it also refers to a shader program. So, this is not generic in any means. This is actually this is from that third-party library. It references OpenGL directly. So, what we would like to do is figure out a way to abstract some of that out. And we're gonna start rolling into. I mean, we're 7 days into this project, and probably a total of, I don't know, 14 or 15 hours. And I'm not as far along as I would like to be, but we're not bad. We're not like, we're actually not too far behind, to be honest. And I didn't have really any direct goals, so I'm just knowing normally how fast I work. At least I realized I was going to be way slower than that, but I just assumed we'd be a little bit further ahead, but it's not a big deal. Let me flip to the scene switcher so things can be a little bit better. Oh, of course. I hate that it does this. I have to basically recapture this scene every day in OBS because it drives me nuts, but it won't let you, like, you have to like set I don't know what the problem is. It makes me relocate that window every day to zoom in. Start, close. Okay, good. Let's just make sure we can capture that whole thing. There we go. We'll just see if I can. Okay, there we go. Splits. So we can remove this split if it starts to be irritating, but it really is helpful at some points to keep the main class right here and be able to do some side work here. So we have some general definitions here. This is we'll just say a formatted version string representing the render version. Clears the render. Although this is where it gets slightly we'll just for now we'll just do this. Clears the render. We're not going to try to make this render capture everything, but we do want it to capture the main aspects. So renders a single IROX object. By the way, these are just comments. I know. No, I got it. I knew what you were talking about. I totally got it. It wasn't, dude. Those are my type of jokes, man. Dad jokes is what they are. So we don't have any notion of a scene yet, so we're not quite there. But what we really want to do is get this into something somewhat abstracted. So let's try this. Let's create a geom package here, and we'll use the interface iGeometry. And it's not gonna be perfect by any means, to be honest. Like and let me check one thing real fast here. Well, I had another window. Here it is. See what a renderable is. So actually, I think what we're going to do, I want to call something renderable, because we're actually calling draw on in the Okay, hold on one second. He is such a drama queen. He is such a drama queen. He's rolling around. I walk over there and I'm like, grab him by the collar, and he goes, ah, ah! He just starts screaming. Oh, he's driving me crazy. He just waits until I'm up here doing this stream, and then he starts rolling around and he's going, ah, ah, like digging his head into my carpet. It's ridiculous. And then I went over there to get him, to tell him to get out, and he went, ah! Like I was killing him. He's like yelling. He's going, help, help. So one of the things that's making this a little bit difficult is the way that this OpenGL API is laid out, because they're including the shader with the vertex array object, which is weird. I get why, but in terms of like design, it's not making this very flexible for us. And so what we're trying to do is we're trying to use a correct design, but we're trying to abstract out that level of stuff. And it's proving to be a little bit difficult, because what we want to have, and what I've kind of come to the conclusion is that we're going to have something, I think what it's going to end up being is we're going to have this iGeometry. Let's just, actually, you know what? Maybe we can do this. I wonder, here, let me turn off scene switcher for a second. And let me see if I can, there is a nice little diagram tool, and I just need to make sure that it's not gonna, really? I gotta register this. Oh man. Oh, that was easy enough. Okay. I like Gliffy. This is a Chrome extension. I'm not going to use UML. UML's esoteric and weird sometimes. But I am going to use this. So the skin's fresh. That's ugly. What is this? Oh, that's nice. Okay, cool. This is so really this is what we want. We just kind of want something like this. Geometry. I'm going to do my best to lay this out so that it's somewhat clear. So we'll just have we'll have this iGeometry, and we'll have iRocks object. And really what we want is something that kind of brings these two things together. And we could call this maybe iRenderable, or yeah, that sounds fine to me. We can come up with better names if we need to. And really what this guy is going to do is just kind of incorporate both these things. Let's see. I know I get to be, when I start making diagrams, it can be a little bit OCD. I'm not going to try to make it too perfect, but I want it to be somewhat clear. So iRenderable, and then we'll have our camera over here, and and then basically our oh man, it doesn't apply the theme universally here. Well, rip. I thought it would apply that. Wait, did that apply the theme? Oh yeah, it did. Well, now. Okay, well, we'll just call this our iRender render. And we can make this a little bit elongated here. And this is essentially what we want is this kind of, we pass here, this gets passed here, and and in turn, this is going to render a bunch of stuff. And so basically what this is doing, in the easiest explanation that I can come up with here, is that we have our camera is basically our view into, and then we could even, if we wanted to represent this even better, we could have our viewport and our view frustum, which is, I haven't explained a lot about, but it's going to be our way to tell whether or not we should render something. and we can draw little arrows here to show that this is kind of all deriving from the same little tree here. And so a renderable is just going to be kind of a collection of this. A Rock's object just carries transform information about an object. The geometry represents the mesh geometry, pretty much like a vertex array buffer, or like the indices. It basically represents the entire the entirety of the mesh. It's like it contains vertex buffer objects, shader, and indices, UVs, normals, all of that stuff. It houses buffers for all of that, and shaders, and we can come up with maybe one more thing called like material that would go in renderable. So that is actually optimally, this is what we would have. We'd have an eye material, and this could be like a color material or a texture material or something like that. But we don't really have that option because this would normally, the material would normally include the shader. But since we're using that VAO object, it already has the shader built into it. Now, we could probably pull texture and some of that into material. We could talk about that later. It's going to be kind of one of those things we may use later. But anyway, I actually I'm pretty happy with this actually, because it seemed it came out a lot more clear than I thought it would look. Let's see. So I may actually just let's move these down. I may actually save this and put it in and upload it, because it where did I put this? Because it just kind of gives us a good map going forward, a good idea of what we're doing. I think it's source. It's pretty weird that it puts it there, but we'll just add a little resources. Well, let's doc, and we'll just say we'll just call it render pipe draft 1, something like that. Anyway, this is what we're going for now, and things will change, and we will probably add more to that, or we'll probably require some more flexibility. There'll be changes to this, but that's for now. That's what we want to go with. So let's try to like create that at least that goal. That's what we want to go for. So so geometry right now, if we look at our OpenGL render, ultimately we're calling on this thing. This thing has a program. Ugh. Eight overloads. It couldn't just be a generic. God, that would have made it so much easier. I really don't want to duct type this thing. But I might have to. Sorry, so let me I'll explain what I'm contemplating on. This right here has set value, has every single one of these overloads. And that's fine. But really, optimally, what we would want is basically something like, it's not going to let me edit that. Ultimately, what we would want is something like set value T. Something like that. So we could just call it once. But if we do that, then we have to duct type, which just means we have to typecast everything to the type that it is. So we'd have to do a is instance of this. If so, then cast it as this. And that defeats the whole purpose of object-oriented programming. So the thing is like the shader is basically not what we want. Let's see. Let me just think here. Let me think. So our geometry, we could almost have geometry except the rocks object. Or we could have we could have it except the rocks object. But that kind of defeats the purpose of having an external renderer. Although, like, what we're trying to do is we're abstracting two layers. We have an OpenGL renderer, which is going to abstract one thing, and then we're going to have another thing that abstracts out the OpenGL third-party library that we're using. So those are the two abstractions we're trying to make so that we can have something a little bit more generic. That way, in case we want to slide in a new render approach later on, we're not limited by our API. We want this to be as clear and decoupled as possible. And so this whole notion of geometry is a little bit tricky because this VAO is a little bit more than geometry. So what I pull out of here into its own implementation is what I'm trying to sort out in my head. And it might just be better to start trying to just work through it versus just staring at the problem trying to fix it. I think that's okay. Actually, we're not going to have...
Come on, kill me, I'm here!
Hey, thank you for the follow. I appreciate it. Especially in my just sitting here staring into the screen like a deer in headlights. This is what we're going to do. Revisiting kind of our diagram, I think that there's a chance, it's not going to be... It's going to try to like filter it out here if I move my mouse over the wrong place, but what we might actually do here, thank you OBS for being a pain in the butt. Okay, I think what we're gonna do here is we're gonna take what I was thinking was gonna be this, and I think that we can get rid of this node completely. Sorry, man. Sorry. I know. Well, it also is cut off. Like you can't hear the whole thing. I don't know what happened, but like they reduced the amount of the length of the sound playback or something for that follow alerts or whatever. They reduced the amount of time that the sound could be. I don't know. It doesn't play the whole sound clip. It makes me sad. I think that we're gonna be able to cut out maybe. I mean, I don't think that it's the right thing, but I mean, I think that optimally we wouldn't want to do this, but I think that right now it overcomplicates things a little bit to try to include this geometry implementation, because we don't have detached geometry. Geometry is part of the renderer, or is part of the rendering. So let's do this. Let me back out of this. So let's get rid of this package and that interface, and instead let's go to this render and let's just start from the bottom up. So let's add iRenderable and get rid of the weird default namespace that I can't seem to change. Defines a basic contract for an entity which can be rendered by iRenderer. Okay. I think the two main what I'm trying to figure out is whether or not we can get by with just using let's see. Okay, let me think about this. We definitely want something like use, right? Because this is what it's a state-driven render pipeline, and OpenGL does a lot of like things. You have to constantly update the state of the renderer before you execute something, and so it creates this kind of nasty API because it's so state driven, and decoupled APIs are typically, they have state, but state is always internal to each object. Like very loosely coupled architectures contain state within each object and not shared state across multiple objects. And when you have stuff like this where you have to update the state of the entire OpenGL context before you before you execute or upload something, then it kind of creates this anti-pattern, I guess. But we want to be able to this would engage the renderable to be drawn. So, and I think that the VAO has something. Yes, use shader has use, and so we'll need something like that. So use this engages the renderable state to be drawn. Let's see, the renderable to be drawn. Bear with my poor off the cuff. And then this is also a little bit of an anti-pattern, but and we'll just put Actually, though, we wouldn't even need to use. We're kind of doing this inversion sort of visitor type pattern here, where we're basically going to visit iRenderable objects with our implementation, and they're going to do whatever they need to do in order to render this thing. But I think this is fine. I think actually this is fine here. So for right now, I don't think we need anything else besides that. So let's create. And what I want to do here, let's separate. Oh, well, no, let's create one internal to that render. We'll just add a GL directory. And we're going to move this in here. And I hope that when we do this, Git is smart enough to understand that I move this. And we're going to put renderable. This is going to be our implementation. Not an interface. It needs to be a class. Guess I was still in the old template. OpenGL implementation of iRenderable. So we're not going to be able to abstract out probably as much as I was hoping for, but we have created kind of this decoupled implementation where we're kind of using like a very rough implementation of like a visitor pattern, but not really, because it's not actually calling back out. So it's more or less just passing it's promoting or passing objects that probably the renderable shouldn't have to know about this. So we are creating a little bit of coupling, but the trade-off is that we're coupling our own APIs in order to decouple the third-party API. And when you start looking at that value for that trade-off, it's definitely in the positive. So let's say this uses the camera and object inputs to apply and render current state. And then our draw is going to look something like, let's come back over here so we can kind of move this. So our draw is actually going to look something like this. And we can actually just copy that over. This is going to have, I'm trying to think. I wonder if let's do this. I think we can make this. I think we wanted to be. Let's not call this Voxel, but let's call this. Let's just call this the model. It's more of a controller, but I'm not trying to stick to any sort of model view controller pattern here. In fact, I would highly suggest getting away from that pattern. Just from experience. And we want to probably pass this. So this particular, so just to be clear here, this is perfectly fine to reference VAO. Whereas we want our renderer, so our renderer is basically our contract. This is kind of what represents our API. So we don't want to reference a third-party member, a third-party library class in our API. And the reason why is if we wanted to make a DirectX renderer, it couldn't reference this because this is specifically for OpenGL. So we need some sort of abstraction of these things in order to substitute in maybe future implementations. I want to go ahead and start decoupling a little bit. We don't have to go like hog wild and basically have 100 interfaces in this insane level of abstraction. I just want our basic capabilities to kind of start in the right direction, and then that way we don't have to go back and do tons and tons of refactoring later. But I am going to try to keep this minimal. So anything that says OpenGL, right? Anything that implements these are contracts can be specific to, can contain specific things as long as it doesn't expose those specific things on our contracts. Easy enough. So, I think this is perfectly fine. I think that having a renderable contain a VAO is fine. I mean, it has to actually. There's no getting around it. It's just whether or not we can make it private read only. By the way, it's mad about this up here because I haven't changed that contract to include or to exclude Rock's object from this. This is basically becoming exactly what we said it was going to be. But instead of having this abstracted one more time, we're just going to take those details and bake them into this class. And you'll see what I mean in just a second. So the renderable geometry for the instance. I love that I just created that twice. God. I need to get my eyes checked or something. So this is how slick this is. We can just set our transformer and our projection directly off the camera object. Our model, we can update our model matrix directly from the model. We select the shader to use, and we update our geometry, or we call draw on our geometry, and that will actually render what we need. This guy, why I might change this later back to what it was is because, let's see, use this camera to draw internal geometrical representation. The reason I might change this back later is because we may want to, so right now, anytime you call render on a renderable, it's setting this. It's setting these values. These two specifically don't change. However, the reason why it's important that they stay there is because the shader might change. So these values are set specifically for the shader. We may not ever change shader. And I mean, we will, but it may be very infrequent. And so setting these every single time we render a different representation of a renderable thing to the screen is going to be inefficient. It's just, I don't think we want to do this because I believe that this actually uploads things directly to the GPU. And we just don't want to be doing that every single time. And so if we if we can somehow figure out a way to reduce these calls, and this is why it's nice to supply the shader separately from the geometry. But right now the shader and the geometry are one thing, and so it's just a hand we've got dealt. So let's just keep that in mind, that right now we think this is pretty inefficient, and that ultimately we would only want to set the model matrix because that would be based on this thing. And then we want to have one public property, and it's just going to be get private set, actually, because we can we're just going to make this a get. Just going to make it a get, and we'll just return model. And I need to give it a name. That's why it's angry. And we'll just do capital model. The model representation of our renderable instance. And then in renderable, we want to also include that as part of the contract, since it uses our stuff model. And we only want to include get as part of the contract. The model representation of the renderable. Okay. We can't change this at runtime. The renderable always includes the read-only model that we supplied in the constructor. We will want factory methods for these things. Factories basically are an abstract representation of instantiation. So you would have new renderable, and you would pass it like maybe this rocks object or something. But we're not going to go that far. Like I said, we're not going to create these abstractions too deep right now, mainly because VAO with geometry is going to prove to be a pain to do without implementation details just yet. So what we ultimately want to do is be able to manufacture our vertices, indices, all of that stuff first, and then we would pass it to a factory for a renderable, and then it could internally generate the VAO and the rocks model. So we're not going to go that far yet. So, but this is actually good. We made good progress with this. This actually looks pretty good for where we are. This is a to-do. Render entire scene. This is a good situation where we would want to ignore the camera piece. And in fact, let's make this. This is going to be our we'll just have a draw, just a simple draw with no camera. Draws the internal geometrical representation. If we are fortunate enough to share a bunch of the same shader, we don't have to set this stuff. We'll just this will be the inferred version of we want it to just use its previous state for the shader. And then we'll have a public void draw. Of course. Wow. Sorry. My this is not my everyday keyboard, and I am struggling. This will actually do something similar to the same thing, but instead of setting these, it will just set the model. And in fact, let's do something, because this is making me mad. I'll be honest, like, I hate this C style syntax. So let's rename these things. Let's call this our projection matrix. We'll just call it projection. Oh, no, let's call it matrix. Model matrix and view matrix. And to be, I really don't, these are internal to the OpenGL engine, so I'm just going to leave them like this. I have to leave them actually like that. But I just wanted to make that clear so it's not I wonder if that's going to cause could we call this light and light? I wonder if GLSL hates this. Let's go to our main real fast so that we can maybe test this. This would be a light. I think it's going to hate me. I think it's going to be mad that I named the struct and the uniform the same thing. Specular, constant, linear, quadratic. Color. I think that's all the shader references. I think. Yeah. Okay. The only thing I would have to change here is this position, ambient, diffuse, specular. I'm just going to try to stick to our coding conventions for C#, even though they might not be conventional for GLSL. I don't really care. I'm kind of peculiar about stuff like that, so sorry if you disagree. My mind refuses to accept other things. Just kidding. Oh, okay. So we haven't actually finished putting all this together. So let's try to do that. So in our OpenGL renderable, we do all this stuff, which is awesome. This is the one without, just a straight up draw. I actually like doing something like this. We need to document this. This is ugly. I might actually just document this. I was going to say off camera, but no, we can do it. But let's not do it right now. And let's organize that a little bit. What I wanted to do man, this might be a little bit tricky. We're not going to implement this right now, but I want it to be there so that we can have a contract basically or something that says let's use this. Is visible, and this is going to be a method that accepts an iRocks object, but oh, it can't do that. It's going to have to be an iRenderable. I think. Actually, let's keep it at rocks object for now. I'm on the fence about this because that is supposed to be like the model. It's not really supposed to. Let's do renderable. Now, we don't have anything on the renderable right now. Determines if the iRenderable implementation is visible from the camera. And so this is important. This will become important later. But basically, any representation of our voxels that we have that we're like moving the camera around, there could be voxels everywhere. But we don't want to actually render anything that's not immediately visible to us. We want to just ignore it. There's no reason to do all that work. So this is why we have this view frustum. This gives us the ability to basically, view frustum has two methods pretty much. It update and it intersects. And the intersects accepts an AABB, which is just an axis aligned bounding box. They spelled it out, which is pretty much just a bounding box that represents the whole, or the amount of space that our renderable takes up. The reason I was like struggling over which one to use here is that I wanted it to be rocks object because the less you pass in, typically the better. However, we can't do that because the renderable is what contains, number one, there's two reasons. The renderable contains the geometrical information, which we absolutely need to determine any sort of bounding box for. And then number two, this would be called from our render function here, which is only going to accept a renderable. And so it has to be kind of this is the least common denominator here is renderable. But basically what we would do here is renderable. We'll just call it bounds, but it's not there yet. So we're just gonna stub this out. We're just gonna return true right now because we want everything to kind of be visible while we're doing this, at least temporarily. And then we'll write a little to do here, and we'll say implement iRenderable bounds. And then actually we're going to implement iRenderable bounds, and we'll call it, and we'll make sure axis aligned bounding box. Okay. We're probably going to end up having to somehow wrap that too in some sort of abstraction because iRenderable doesn't reference any of our specific stuff, if you remember, or any of the third-party specific stuff. Although the math library is kind of decoupled from the OpenGL stuff. But anyway, I mean, I know we got 8 people in here. I absolutely do not. It does not bother me at all. If you're just lurking, just want to listen, just want to stand by, even if it doesn't matter. But I do want to know if anyone has any sort of questions. They can be specific, they can be general, they can be whatever. I just want to take just a breather here and just kind of make sure that, what's up? I actually encourage the lurking. Like if you just want to hang out, that is awesome. But I do want to make sure that you guys, like, if you have any questions, if you want to comment and say this sucks, like let's do something else, just unleash the fury. Mitch, unleash the fury. Oh, that's hilarious. How you doing, man? How's it going? I'm So we're gonna mark this to do real fast, and when we mark this to do, this is a feature of just about every IDE. Well, I thought it was. I'm gonna get caught in a lie here. I thought view, not error list, other windows maybe. Can we see to-dos? It's gonna irritate me. I've been using, at work, we use ReSharper, which is JetBrains. I don't know if you're familiar with JetBrains. They're very popular in the Java world, but they also have just incredible software for pretty much every language you can imagine. But they have a Visual Studio extension that just adds some of the best features for C# and any of the .NET languages really. Oh, we are moving very slow. Half of that is on purpose, half of it is not, but we are moving very slow. We're moving very slow. This is probably, I would say, moderate in terms of how advanced it is. We're not like, you could absolutely just kind of follow along if you wanted to. And the thing is this is why I'm encouraging the questions. And no, this is not like an elitist channel by any means. Like, please stick around, learn, ask questions, whatever. It's for that reason. I'm kind of doing this to as a means of open source plus actual explanation and walkthrough sort of thing. But we are coding what is currently the plan is just to kind of move forward and write some sort of basic Minecraft-like voxel engine that has fairly basic to a Minecraft-ish voxel engine, and just kind of walk through it clearly and open the door for things like maybe using DirectX or adding additional features, terrain generation extension, that sort of stuff, making it as flexible as possible so that people can take this API and the code that we're open sourcing and do something with if they want to. If they want to build a game or if they want to add on just for their own enjoyment, then they can. So that's really right now. But you know, I've said it a couple times. This project is basically what we kind of want it to be. We don't have to go to one abstract approach. We can make it specific. We can build a game. I mean, we can do whatever. I'm open with it. It's kind of for education purposes as well as like what I'm personally getting out of this is just kind of a refresher on a lot of this stuff and practice in C#, which I've been professionally a C++ programmer for like the last 5 years. I've just started a new job where I'm primarily doing C#, and so I'm trying to stay sharp. No pun intended there, but I'm just trying to stay sharp on my skills, and the older I get, the harder it gets. So I don't know where this toolbar is or where this window is, but I'm guessing that maybe it's not here, and that makes me sad. But sometimes in a lot of IDs, there is something that marks your to-dos and will show you a gigantic list of them all. And so you can go back later and start iterating through. Yeah. Dude, bots are it's I will say this though. It's nice to have a very specific goal. Um Sometimes like programmers because we think we're forced to kind of think abstractly a lot. Our ideas become kind of abstract, and that's really unfortunate because it can be really really hard to build something that you don't have clear uh a clear set of goals for. And so I will say that you are part of the battle is planning and knowing what you want to build. I mean, clearly, I just actually went through 2 seconds ago when I was talking about what we're building. I don't really have a lot of clear goals, so I can kind of ramble and move around, and might not get much done some days. You know, Python is great. Um, I unfortunately forget Python the moment that I have to write. If I have to write anything in Python, I will spend a couple hours just kind of struggling through it, having to learn syntax and stuff. And then once like I feel comfortable with it, I'll put it down and I won't have to use it for years. And then I come back to it and it's the same story. I I will completely forget everything that I had learned. But Python is great and it's so widely accepted, and it's in most cases it's 100% cross-platform, and I mean, at least for the major platforms. And it's lightweight. It's easy to like write things that do a lot with little amount of typing, and a lot of people know the language, to be honest. But if it's for your own personal, project, then sometimes you don't need to pay attention to all those details. You can just write with whatever you feel comfortable with, but Python is probably one of the easier ones to learn. Given that I have to basically learn it every single time I want to do something in it, I would say it's one of the easier ones to learn. Okay. Anyway, we're gonna stub this out. This is visible. Um, we don't have any of these APIs yet, but we will eventually. So, okay, let's move back to this OpenGL implementation of this renderer. So, this thing currently accepts a rocks object and the geometry. Well, we just took these two things and we abstracted them into a iRenderable. So now this iRenderable exposes the object, the rocks object, our target transform information, and has two methods: draw with a camera, draw without a camera. With the camera is just going to reset the projection and the view matrix. And then draw is just going to use the same shader, but it's only going to set the model matrix. And we'll use this as an optimization. If we share the same shader program, we're going to just use this versus having to reset those values every time. So with that being, let's see here, let's actually pull this renderable implementation over here. So we now have our geometry and our model are now part of this renderable, and it's doing this work. So now our render method no longer needs to have these two things passed to them directly. And the reason why this is important is this VAO is not part of our engine. It's a class that our little OpenGL platform and bindings for CSharp. Why does Docker Compose get? I wish Visual Studio would stop adding crap to my projects. Thank you. All right, I think that's it. Wait, packages? No, that's for NuGet. App config? NuGet. No, that's just for app. Okay. Anyway, and we want to abstract this out because we don't want a third-party library API, at least for right now. We don't want it in our we don't want to expose it in our core Voxel engine API. So we did some work to abstract this out. We need to update our documentation here to be renderable. And we'll do a single renderable to the screen. Camera, render, rocks object. So we've updated this stuff. Let's kind of go back to our OpenGL renderer. Then we can update this as well to now just include an iRenderable. Renderable. We're going to update our viewport, and it's going to be as simple as renderable draw camera. Now, really what we want to do is this. If camera is visible, renderable, draw. That's why we stubbed this thing out. But if you remember, we just return true right now. But it will use the view frustum and the bounding box for the renderable to determine if any of that stuff is in view. And so when we come back, let's go back to our main class here. I'm gonna pin that or whatever. We're about to figure out if my shader changes are going to cause problems or not. So our let's see. This is what we're going to do here. Private iRenderable cube. We're going to remove these guys, and we're going to have this. And we're going to say cube equals new renderable, our new cube renderable. And we don't have a method like that, so we're just going to, I think we can create it, Alt-Enter. Yes, generate. God, I hate that it keeps giving me that inline crap as the default. Cube object, var cube geometry. So just so it's clear where all this stuff is, it's all right here actually. And we can walk through this really fast, but cube.model is going to be what it's looking at. And okay. And actually, let's iRender. We'll kind of mimic factory methods at this point. We'll just say new renderer. And we'll just return a new OpenGL renderer. So we're just going to kind of mimic this. Basically, the type for our renderer is iRenderer. The type for our cube is iRenderable, but you can very clearly see that we're returning OpenGL specific implementations of those. So we want to return a new OpenGL renderable. Wait, isn't that what I called it? Yes. And actually, we updated this, so this probably needs to go in the GL package. excuse me. Good. And this will include our cube object and our cube geometry. So here's what's neat. We've kind of reduced the object and the geometry into one nice little renderable package. I'm going to move this stuff down here. I just want to, we're going to walk through it just to kind of get an idea of what it's actually doing. Creates a new renderer instance and creates a new cube renderable, and this creates a new cube geometry VAO with a light shader, and this creates and sets default values for our light shader. And vertex shader to source. This is our GLSL fragment shader. This is this is our vertex shader, and this is our fragment shader. That has gotten a little bit complicated, but not really. I mean, it's very basic, but it just has gotten a little bit more complicated than it was. So what this actually does is kind of going, if we start from the very beginning, what we did was we created, we just had a bunch of matrix objects floating around in this main class, and we had a bunch of random setting of things, and we had VAOs, and we had all this stuff. And what we sort of did was take a step back and say, okay, well, let's take all of our specific to object stuff like transform and rotation and that level of stuff, and let's abstract that out into a rocks object. And so this rocks object has sort of like these helper methods that do things like move and move to and rotate and look at and all of these other things. And then let's take our view, our projection, and let's abstract that out. And that gave us a camera, which is also a rocks object, because we want to be able to rotate and move a camera. So it makes sense that a camera is just an extension of rocks object. And this is going to add some things like projection, view, and viewport. And our viewport is basically just a rectangle, X, Y, width, and height, and an aspect ratio. So we've abstracted all these representations of these things. And here's the shader and the VAO creation. And then we realize, okay, well, we want our API to not necessarily depend so heavily on this external API. Even though it will depend on it, we just don't want to make that relationship as noticeable. I'll say we want to decouple that relationship. We want those things to be separate, but we still want to be able to write classes that use the third-party library. We just want them to meet our API's contracts without exposing what we're doing on the inside. And I believe the let's see, cube geometry. This is going to be tricky because all of this stuff uses unmanaged objects. And I constantly am wondering how that's going to manifest in our stuff. Like, I don't know if every single class that we do that references one of those objects, I don't know if it means that we have to use like the dispose pattern, because I hate that. I'm not even, it is my least favorite thing about C# is there's this weird disposable pattern that you could implement that is just disgusting. But it's essentially a way to like bypass the garbage collection, or sorry, it's a way to trigger on garbage collection, but you have to actually do all of your collection because you're using unmanaged resources. What's up, Colt? How's it going, man? So, what just reminded me of that is this. It's telling me that it doesn't like this. And I don't want to manually dispose of something. God, it's going to make me so irritable. Although, when we created this stuff, I kind of feel like dispose children, dispose element array. I'm going to open up this library right now and see if we can... We're going to save, but I want to see if we can determine what this actually means. Where's VAO? So if we set dispose children, what does this mean? Oh, this actually also sets dispose element array. So actually, when we go back, we don't have to manually set that. But what does it mean? Yeah, I mean, that's what I was saying last night. Or why not have your generation do the sampling while it's generating? In order to avoid generating and then sampling. Why not just do it in one step? Why not sample as you generate? So if dispose children, it's going to delete all this stuff. Delete vertex array. Oh, this is all disposable. This makes me sick. It doesn't dispose of the program, does it? No, it doesn't. Oh, man. Okay, I guess that makes sense why it doesn't. But I think that because of that, I think we have to manually... Wait, dispose... What is dispose faults? Oh my gosh. Dispose faults. It would bog down? What do you mean full scans? You're generating something. Like, what you're saying doesn't make any sense to me. You're generating something. While you're generating, you have to know what you're generating. You can't just generate some magical thing. Like, you have to pass things to the generator so that it knows what to generate. So if you say generate the voxel at 5, 0, 1, and it generates a thing, then you know what it is. You get back that thing. It wouldn't bog down load times because you're already doing it. You're already getting a value based on some input. So you're not doing a full scan. You're just doing it at the moment that you generate something. I think that you are trying to attach your specific implementation to a very generic context, and it's not happening. What about adding one small sample to each thing makes it expensive? I'll give you a hint. It doesn't. It doesn't at all. Unless the way you've implemented it makes it expensive. I mean, I don't see any way that could possibly, adding one method call is going to be any more expensive than the generation is currently. I can't wrap my mind around that. And if it is, that's where your problem is. And you need to really look at that piece of code. Vertex, normal, tangent, UV, element array. Blowed away. But why? So that object is actually getting... But we're gonna end up suppress. I don't know how this stupid pattern works. Sorry, I don't know how this works. So dispose true, suppress finalize. Dispose just causes dispose true, but we don't even check this. So okay, so let's do this. Let's just test this. I have a feeling this is not going to end well, but. Let's set these things. We don't actually have to do that anymore. Dispose children automatically sets that for us. Let's actually just add. This sucks. I don't want to add this. This makes me so irritated that I have to do this. I'm not going to do this right now. I'm not going to do it because I think it makes the design so disgusting. Let's just keep a reference to the shader program for now. I don't really want to. God, this is awful. So I'm going to tell you what I'm doing here. We need to dispose. We have to manually dispose of the stupid of the shader program. Which, thanks garbage collection, I guess, or not garbage collection. So when we create our shader, we're just going to keep a reference to it, and then, and here's the thing, is like normally it wouldn't matter, but if you don't dispose of this stuff, when you close the scene down or when you exit the app, it actually will throw an error. Like, that's what I'm saying. It's like ridiculous. It's like, it's such an anti-pattern. It's such a load of shit. I mean, that's all I can really think of. It comes to mind is load of shit, because it is. I mean, it's like, okay, I get it. unmanaged resources have to be disposed of manually. But why is that not being hooked into... Maybe it is. Maybe I'm just crazy, but I feel like it's not being appropriately hooked into garbage collection semantics. Colt, I can't wrap my head around what you're saying, because generation implies scanning. You are generating, unless you have, the only thing that I can think of is that you have something that looks like this. Let's do this. Let me just load some here. All right, let me actually finish my train of thought, and then we'll talk about this. We want to render the main camera, and then we just want to pass cube. But cube is now a renderable object, and then we're going to swap buffers, and we're going to call it a day. Except for I can almost guarantee that my shader is going to crap. But we'll see. Womp, womp, womp. Okay, actually, you know what? Awesome. I just forgot to rename one thing. It actually worked. No, it didn't. No, it didn't. Oh, man, that sucks. Okay. Okay. We'll just call this main light, and we'll call this main material. No, God, that's so lame. You know what? Main light is fine. No, it's not. All right, you know what? Screw this. Right now, I'm just gonna lowercase these sons of bitches, and then we're gonna move on, because I don't feel like battling syntax right now. This should be good. Okay. The exception I'm getting is a little bit misleading. The exception that I'm getting says that it cannot find in position, but really what's happening is the shader itself is failing to compile. And because of that, when I try to set the in position on something, it explodes. But this is somewhat easy to at least get some general debug information about. This is going to be, we'll do vertex shader. And then we'll pass in, and what this does is this is going to let us get shader. We'll do vertex shader dot shader log. So that's going to give us the log from the compile. So we can see where these errors are. And this took me a while to grasp. But so we still get the exception, but now we can come over here to our console window. Wow, look at all the errors. This is what I'm talking about. God, that's freaking awesome that you can get that many errors out of this. No field and structure constant. Dude, wow. I'm slow. I didn't update all the stuff inside ambient diffuse. I honestly think that this would still work. Constant, quadratic. Let's see if this doesn't work. Although I do have to change this and this. This to actually use the right thing. I'm making sure here that this has to be light dot position. Maybe? Okay, it didn't, but let's see what okay, so the error is a lot smaller. Redefinition error. Okay, so that's pretty indicative that I cannot name my uniform the same as the struct definition. So that's what I originally thought the problem was, and so clearly was a lot more than that, but this helped us kind of whittle this down. So we'll just update material color, all that stuff, and good. That's still setting the same stuff. Okay, so here we are. We have our little shaded cube. Hooray! And of course it explodes. So you want to know before you generate. Good luck. You're basically saying I want free optimization. I mean, at least that's what I interpret that as. I want you to think about this. So, you have generator. Actually, you know what? I'm just going to use one big thing so we don't have to worry about syntax. You have generator. You basically want to do something like I mean, this is what I don't understand. We could just say like chunk. Let's call it like chunk flyweight or something, because that's what it is. That's where it's a representation of what a chunk may be. Generate, and then we can have like something like this, like chunk equals generator dot generate, and then chunk flyweight or whatever. I mean, it doesn't really matter. And then we can like what octree push chunk, whatever. So what this says to me is, in order to be able to do this, chunk flyweight scan, and then we could say, we could give it an interval. So if you're 16 by 16 by 128 or whatever, let's say that the scan, you want to do a 4x4 by, like a 4x4 by 8 scan. This is what this is doing. If you want to do a lightweight scan early, it's got to do this work for every chunk. If you have to come down here and generate it again, I mean, even if you reuse some of the scan data that you found here, you're still going to have to generate. If you find something, you're still going to have to generate again. This is essentially going to scan again. So for all things that are valid chunks, you're going to end up basically scanning through them twice. And the thing is I get what you're saying. Like, even if your empty chunks are 75% of all chunks generated, quote unquote generated, you're still paying for it twice for 25%, right? It's the cost is still going to add up. Like, I don't think that you gain enough to make the effort to optimize all this, because this is still at the same time, like, to me. Now, one thing you could do is you might be able to do something like scan aheads. And the thing is like, dude, this generation, like, I don't think it's hurting you to just generate this stuff on multiple threads. Like, generate it all. Like, create a thread for every chunk. I mean, not really, but, create a thread pool of like 8 threads that are sitting there on a blocking queue that as you add things to that blocking queue, it's just going to peel things off and generate them as fast as possible. That should be an expense that you're willing to just eat, because generation needs to be right. But generation just creates the data that you would pass to the GPU. Like, if you're generating on the GPU, don't think that's necessary. I think that's actually probably not the way to go. Just my opinion. It might be fancy, but that's you should keep generation to the CPU. Again, you're going to have to, whatever data is created on the GPU, you have to pull it off. And that operation of getting it from the GPU can be just absolutely detrimental to overall performance. And so I think that you, like, even if what you're doing is just trying to learn more, then there's no argument. I mean, do whatever you want to do to test things. But I think if you're putting generation on the GPU, I think that's too much. I think that's a little bit overload. All right. So this is getting to be okay, well, you can stick with that. But I think optimization is gonna prove to be really difficult. I mean, and again, it depends on what you're going for. I mean, the parallels between your approach and this approach are going to be non-existent. We're going to do some things GPU bound, but if anything, I'm going to prove that we can use the CPU and be just as effective in this sort of approach. And in the end, we're going to have, I mean, object-oriented programming is designed for ease of use and easy to scale APIs. You can't really do that. The moment you put things on hardware that's difficult to access data or expensive to access data, it limits your APIs a lot. Yeah, I know. It's because of Mono 3.5 or whatever god awful fork they used. I agree. But if you are interested in using some I think I posted this earlier, but this library is fully compatible in Unity, and you can use this class a blocking queue of action and you can create, I don't know, just loop through, create 5 threads, and each thread should just be like while not shut down queue deck. A queue.deck and then A, or something like that. And basically, it's going to block. That's going to block if there are any, if there's no items available on the queue, then it's going to block. And so those threads are going to sit there waiting on things to get added. And as you add actions to that, it's gonna peel them off and execute them on whatever thread is got through to deck the action. And that's going to give you a up to however many threads you have. So if you have 5 threads and you're adding things, it's going to use all 5 if it's not done executing whatever it's done. I mean, you could make it 10 threads, you could make it 20 threads. I would keep it small. I'd keep it like 5 or 10, 5 even. But I did this for mine, and it seemed to be fine. Yeah. No, I get it. I think having GPU generated voxels is like, I just think it's a little bit much. Does the hardware have built-in noise, or are you actually having to implement noise functions as well? If the noise functions are built into the card, meh, you may be onto something. So what was this thing mad about? It was mad about something when I closed the window. What was it pissed about? It's mad about VAO dispose. Why won't it just let me? I hate this stuff. Dispose scene. I just don't want to call dispose. I don't want to call dispose on this thing. But it's basically blowing up. It's not, I mean, the GL context is going away and then it's trying to dispose of this stuff and it's really aggravating. I wonder if I just like what if I just set them to null? Of course. Doesn't matter. Stupid garbage collection. Oh man. Okay, well yeah. Awesome. So annoying. I don't know how I want to propagate all of that through maybe I should just like add my I just don't want to add dispose to this. I just don't want to add that. I guess I am. I'm not going to implement the C# version of disposable though because I hate it. And clearly the GL context is going away before any of this gets called, so I can do this. I can do this manually and I don't have to implement disposable because disposable isn't going to help me, unfortunately. That's what's annoying, is that disposable, the whole disposable pattern is supposed to help. But what's happening is I'm closing the window's going out of, the context is getting destroyed. The OpenGL context is getting destroyed, which will actually destroy any of the associated or attached data that came from your app also gets destroyed with the context. And then what's happening is all my object representations are getting garbage collected and it's going through and trying to delete vertex arrays and stuff like that, but the context is already gone, so there's no reason to delete it. And so it's throwing an error, which sucks. So like basically garbage collection is screwing me here. Because it's acting like the context should be the last thing destroyed and it's not. No, he did it. I'm not implementing iDisposable. That's over my dead body. I'm not doing it. And it wouldn't help. You know what I mean? Like it would not help this scenario at all because no matter what, if I let the runtime call dispose or call the destructor, which we'll call dispose, it's still going to throw an exception because this geometry.dispose is actually trying to blow away the GL context stuff. And the GL context is already long gone by this point. And so it's not going to work. It's not going to work at all. Anyway, this should unfortunately. If it doesn't, then I'll yell some more, and then I'll feel better. Because that's all this is about, is good feelings. Oh, God. It will be easier to manage when we have scenes that contain lots of things. There. I think we still want to maintain a reference to our program because our shader can be shared across renderables. So I don't want to remove that. Did we delete rotation access or axis? I guess we did. I'm gonna be sneaky. I just want to add some stuff to see, just to make sure our so let's just add like a nifty little rotation. Actually, forward is. Oh, we don't care about that shit. Get that out of here. Get that out of here. Heyo. Cube dot model dot rotate. Of course it doesn't work. Fuck. Really? Really? I knew I broke this shit yesterday. I knew I broke it. Damn it! Damn it, Bob! I'm a doctor, not a pool man. Yeah, I knew I broke this yesterday. I knew I broke rotation. And I don't think I'm going to be able to fix it in the amount of time that I have left. So, let's look at it real fast. So the reason why this isn't happening is because when we update our transform, oh, we're calling look at every time, aren't we? No, we're not. We're not calling look at, but when we see, when we rotate, we're creating that. This seems fine to me. Rotation dirty equals false, but that's. See, this is too much work. We shouldn't have to do this. I need to figure out how to make this happen without explicitly doing it. Because this shouldn't happen. The only thing that should really happen is that we should be able to derive this. Update rotation. But the problem is that once we rotate, we need to do this, which is shitty. Man. Oh, man. Oh, man. Oh, brother. none of this is hard. I need to just rethink a lot of this and how to approach it, because I think I just spouted a bunch of nonsense into this class, and I just don't think it's gonna. I think I just need to kind of go back to the drawing board here, and figure it out. Because really what's happening here is we're rotating stuff, but it's not doing anything because it's not updating the transform at all. And the biggest problem is that the transform, well, actually, you know what? Let's try this. Yeah, that's not going to work either. So what's happening though is that we are what's happening is that I think we're applying this and we're getting this new rotation matrix, and then we're turning around and we're blasting it using the look at. So rotation matrix is actually updating correctly, but what's happening is that our look at is absolutely blowing away the rotation. So when we update our transform, so maybe we should do like this. If update rotation update transform. Oh yeah, that broke everything. True. Maybe. Yikes! Oh yeah. Okay. Yeah, that's unfortunate. All right. Well, you know, we'll figure out how to fix that later. So anyway, I'm gonna leave this at it. We do have broken code here. We're not gonna be able to rotate things, but let's see. Let's just really quickly. Let's just make sure we didn't break movement. That will make me feel a lot better. So let's actually have it move. Well, this is kind of silly, but we'll make it. Let's make it move 0, 0, and then rotation. This is dumb, but it's going to move slowly backwards, I believe. Yeah, there it goes. Let's actually have it increment like a much smaller value, so it moves slowly. So, and it's moving away from our light, which is funny. So you see how that's just ambient light that we're seeing right there because it's moved too far away, but we're chasing it down with our camera. Okay, good. So the good news is that movement did not break, but rotation totally did. Well, Colt, this is what I'm talking about. Like that's why you want to have. That's why things are better on the CPU in a lot of ways, because you can control things like that. If you only have some generic GPU function that just does shit tons of work and you can't like drill down into the components of that and make changes that matter, then the thing is the GPU solved all problems. We do everything on the GPU, but we don't. We do a shit ton of things on the CPU because it's in a degree, or in one way, it's better because it gives you more flexibility. And part of writing good programs is flexibility. And there is a balance. And if you do too much over optimization, micro optimization, then you lose the ability to do certain things in your application. So if you have this brute force GPU generation, then you either, one, have to figure out a way to orchestrate passing things to that GPU generation that allow you to query whether or not something is empty to a certain degree. You either have to add that or you have to move it to the CPU. And you can fight it all you want. You can be stubborn about it, but I'm just kind of giving you my take on it, is that you have something that's a little bit too overdone and complicated, which is the GPU generation. And the thing is, like, you can tell me that you read an article that says that you should do GPU generation on the GPU, or that you should do generation on GPU. But if they're not telling you, like, hey, well, yeah, the problem arises of having to, how do you optimize that? Or what happens if they're empty chunks? Well, then that's not really a good suggestion on their part. And so I think that, you can take any amount of information from GPU gems or whatever, because I think it's great. I think GPU gems is amazing. And the articles written there are incredible. But you also have to realize that these guys are writing in a bubble. I'm just telling you from my perspective, what you're running into is based on over-complex algorithms on the GPU that you can't really have access to as part of, like, your regular program. And I don't buy that you can't use the CPU for that. I don't buy it. You could say it's just too slow, but I don't buy it. I think you're overloading the GPU with, if you're like, what you need to do is that if you're using compute shaders to render the things, then you don't need to be using them for generation. To me, it's really that simple. If your generation is a bottleneck and you want to be able to use the GPU for that, then you need to use the CPU for other things. You need to find a balance. You don't need to load. Why are you not loading things on the fly? Like, why are you not, like, constantly generating and pumping things in? It's because because you're trying to do everything up front, and so you're doing all GPU work to generate, and then you're doing all GPU work to render. If you generate on the CPU at a kind of consistent pace, instead of just loading the world in all of its existence, make it dynamic. Make it so that you're constantly loading things if you're moving around. You can do that background load with the CPU, and you can pop things in, always just rendering with the GPU. And I don't see why that's such a difficult trade-off. I am using OpenGL for Sharp, but it's a fork. This is it right here, Java. I have pushed a pull request to support GLSL structs. But I have to bail, unfortunately. So you're creating contention with the GPU anyway by loading and rendering on the GPU. So to me, that's kind of a no-brainer, unless I'm missing a big part of that. But I have to run. I got to get the real work. But I will probably be back tomorrow morning. We can continue this. I'll make sure everything's up on GitHub. Thanks for hanging out, guys. Talk to you soon.